Hi guys, welcome to the short videos. We are learning maths with Mazhar. Today we are solving CBSE grade 12 final exam preparation for the students who are appearing. So let us solve quickly the problems, very short and the short marks at 1 or 2 mark questions. This one is for 1 mark. A question which is given 2 raised to cos square x. So this you just have to relate it, derivative of a raised to x. How do we do? The same thing that we will do. It is nothing but a raised to x log a, which is as a base, not as a power. So here your a is 2 and x will act as a cos square. So basically what we do is chain derivative. So let us take this function equal to y, and then when we do differentiate it, dy by dx is equals to a raised to x log a, and then as I said, chain derivative of cos square x, and cos square x is nothing but will act as like cos x whole square. So when we do it like x raised to n, it would be so 2 cos square x log time 2, then derivative of this one, as I said, x raised to n, so 2 cos x, and again derivative of cos x will be nothing but minus sin x over here. So 2 cos x minus sin x, 2 cos x minus sin x, so there is a mistake, so negative sin x, and this thing you just plug in as it is. And now 2 sin x cos x is nothing but sine multiple, that is sine 2x, negative outside. So 2 cos square x sine 2x times log 2. This is your final answer for the differentiation of 2 cos square x. Moving on to next question, which is of the definite integral. We have the limits minus pi to pi integral sine cube x cos square x. So we have a property, if you could relate it, like minus a to a f of x is equals to either twice of 0 to a f of x when it is even function, and it is 0 when it is odd. So how do we know whether it is even and odd? You have to use this one. Just plug in place. This is my f of x function. Now f of x is nothing but sine cube x and cos square x. What do you have to do is just plug in place of x negative x and cos square negative x, and check whether you are getting, if you substitute f of negative x and if you are getting positive, that's called as even, and if you plug in f of negative x in place of x and if you are getting negative of that, it is odd. So as you can see, sine of x is minus, so I can clearly state, and cos square negative x is going to be positive only, because cos negative in the fourth quadrant positive. So when I have substituted x as minus x, I am getting negative of x. It means it is odd function, so therefore my integration answer would be 0. As simple as that. For 1 mark you don't have to elaborate it, just use this property, right, show the working rule, and your answer is done. Moving on to the next question, which says write the order and degree of the given differential equation. So order is pretty clear, that you have to check the highest number of times that you are doing derivative. So here in the bracket it is 2 times that you are doing, but the entire, this is the highest because you are doing it 3 times. So the order is going to be 3. And for the degree you have to check whether it is written in the proper polynomial in derivative form, whether log or e raised to x is there or not, because it may be defined, it may not be defined. So it is properly written in the polynomial form of derivative. So we can say yes, degree is defined, and it is nothing but whatever is the order, its exponent, even if it is nothing, as we take it as 1. So degree is 1. Sometimes they may ask you to find the sum, you can say it is 4. Moving on to next question, which says if a matrix is both symmetric and skew symmetric, then prove that it is a null matrix. We need to show that it is a null matrix which is both. So let us define a matrix, just call it as A. Let A be a matrix which is both symmetric as well as skew symmetric. So as per the definition, we can say A dash is equals to A if it is symmetric. Okay, and if it is skew symmetric, we know the transpose of the matrix will give us negative of that, or basically additive inverse. So now if you take up these two, let us call this as equation 1 and equation 2, and if I equate it, what I'm gonna get is A is equals to negative A. If I shift it over to the other side, A plus A will give me 2A is equals to 0, and A is nothing but 0, which is nothing but a matrix. 0 means it's a 0 null matrix. So that's our proof. I hope you like the video. Please like, share and subscribe for more such videos for the upcoming CBSE final grade 12 examination, which is going to be in the next year, March or April. We have to just wait for the signal from the education ministry.